The new Portable, Reliable, Remote Methane Leak Detector, or RMLD, is changing the way methane surveys are conducted. This revolutionary new device is changing leak detection by offering a more efficient, safer way to detect natural gas leaks. Now, instead of having to walk the entire length of the service line to check for methane leaks, the remote methane leak detector can quickly and efficiently detect leaks up to 100 feet away. Because it utilizes a new laser technology, the remote detector enables surveys of hard-to-reach areas and difficult terrains. For utilities and their employees, this new time-saving method represents the potential for significant productivity gains, reduced operations and maintenance costs, and is a safer survey instrument. Available gas detectors that deploy technologies such as flame ionization must be positioned within the leak plume to detect the presence of methane. The new remote methane leak detector does not have to be within the gas plume because it uses laser technology known as tunable diode laser absorption spectroscopy. When the laser passes through the gas plume, the methane absorbs a portion of the light, which the RMLD then detects. This quantum leap in technology makes it possible to detect methane leaks along the sight line without always having to walk the full length of the service line, thus increasing productivity and reducing safety hazards. Using laser technology, remote detection allows the user to safely survey areas that may be difficult to reach, such as busy roadways, yards with large dogs, locked gates, pipes suspended under a bridge, and other hard-to-access places. Because the RMLD is operated outside the leak area, it is safer to use and allows utilities to realize an increase in productivity by reducing a number of inaccessible or dangerous survey factors. Further aiding a utility's goal to protect life and property, you can aim the RMLD through a building window and verify the presence of large amounts of gas inside. The remote methane leak detector consists of two interactive components: a laser emitter receiver subsystem and a signal processing user interface controller. The laser emitter receiver has two lasers. The infrared laser is non-visible, eye-safe, and is continuously on while the unit is turned on. The green spotter laser is similar to a presentation pointer laser. This laser is under the operator's control and can be turned on by depressing the trigger button. Avoid staring directly into it and be courteous to others by not shining it into their eyes. Also, be careful not to distract drivers. The RMLD has proven itself to be highly effective in a variety of utility field studies. In the independent validation tests, the RMLD has proven to be a highly effective leak survey instrument compared to flame ionization and similar equipment, but with the added advantage of remote detection. The RMLD achieved significant productivity gains that drastically reduced operations and maintenance costs. Here's how it works. An invisible IR laser beam is transmitted from the launch port. To detect leaks, some of the laser light is reflected by the background surface back to the detector. This reflected light is collected and converted to an electrical signal that carries the information needed to deduce the methane concentration. With a normal background such as brick, concrete, or grass, the laser has a maximum distance of up to 100 feet away, and the laser light beam width is about 22 inches at 100 feet. It's important to note the laser light is selective to methane only, so it will not register a false alarm on other hydrocarbons or water. This signal is processed so that methane concentrations can be reported in parts per million meter, or ppm-m. ppm-m is the methane concentration times the width of the plume, while ppm measures absolute concentration. For example, the leak is creating a gas cloud of 1,000 ppm and is about 1/2 meter in width. The RMLD will read 500 ppm-m, while a FI would read 1,000 ppm. The RMLD uses a system of tones to indicate detections, concentration level, or fault conditions. The higher the pitch of the tone, the higher the concentration level. No sound at all will indicate a low light level condition or instrument fault. While using the digital methane detector, or DMD, no sound will be heard until a detection of methane occurs. The pitch of the sound will be relative to the methane concentration. The higher the pitch, the stronger the methane concentration is. In order for the RMLD to detect gas, 3 conditions must be present: a gas plume of sufficient size and concentration, a sufficient reflective background, and the laser must pass through the gas plume. Proper survey technique is essential to accurate readings. The first thing users will need to learn when surveying with the RMLD is to control the aiming of the laser and rate of sweeping. A smooth sweeping motion and steady rate of distance change is preferred. The laser works best when scanning at a distance of 15 to 20 feet and beyond. Use the green spotter laser to effectively know where you're scanning. Care must be taken to scan typical areas where leaks will vent, like cracks, edges, repair patches, and meters. In the event a leak is detected, the technician then needs to verify it. Larger leaks are easily verified by sweeping the laser in and out of the plume. In the event of a very low-flowing or venting leak, verification takes a bit more investigation. The RMLD can be easily used to determine if the leak is located on the meter or underground. The Remote Methane Leak Detector. This revolutionary advance in leak detection technology is changing the way methane surveys are conducted. Faster, safer, more reliable, more efficient. Hands down, the RMLD is the better way for detecting leaks. Putting accurate readings at your people's fingertips without putting your people in harm's way. For more information about the Remote Methane Leak Detector, contact Heath Consultants Incorporated, the leader in leak detection products, then, now, and tomorrow.